Hi everyone. Today we're going to look at distributions, and actually today's lesson is really only going to be on binomial distributions. You'll have a follow-up video for the normal distributions. So binomial distributions. So first of all, let's talk about what a binomial experiment is. And so there's many probability experiments that can be done where there's just two options. It's either a yes or no, or true or false. Some sort of a success or failure. Our example today is Jayhawk or Wildcat. Okay, there's no in between. You can't choose shockers. You got to pick Jayhawk or Wildcat. And so in this binomial experiment, anytime you're doing that, there's independent trials, which means you're surveying n number of people, whatever that is, 20, 30 people, and they're independent, meaning what one person says does not affect what the next person is going to say. And there's only two outcomes. It's either got to be a success or a failure, in our case, Jayhawk or Wildcat. Now, the probability of a success is generally given to you, or you can figure it out, and we call that P, which means that the probability for a failure is 1 minus P. In other words, if the probability of a success is 0.1, then the probability of a failure would be 1 minus 0.1, or 0.9. Okay, so doing a binomial experiment. Now in class we went ahead and did a survey of this. I'm just going to throw some numbers in there. Let's say that we did our survey and 0.8 or 0.8 of the students were KU fans, which means 0.2 of them were Wildcat fans. All right, write that down in your notes because we're going to use those probabilities throughout the lesson today. Now, knowing those probabilities, what we're looking at today is if I'm going to then, knowing that those probabilities are given, if I take a sampling of people, in this case I'm going to ask 5 people, what's the probability that I get exactly 3 of them to say a success? And so in our case, a success is going to be, of course, a Jayhawk. Not because the probability is higher, but because I like Jayhawks better. All right, so here we go. The combinations. Oh, well, not even that. Let's just look at the probability of getting those Jayhawks. So let's see. I'm going to ask 5 people. I need 3 to say Jayhawk. So the probability of a Jayhawk is 0.8 and means multiply. Another Jayhawk and another Jayhawk. And then I need 2 Wildcats. And so if I multiply those all together, what I end up with, let's type that in and see, I get 0.02 for a probability that if I'm asking 5 people, that exactly 3 say Jayhawk. And that seems a little odd to me. That seems awfully low. Considering that we're predominantly Jayhawk fans, why would that probability not be higher? Okay, well, it is wrong, actually, because here's what I'm doing. I'm forcing this to go Jayhawk, 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 Wildcat, Wildcat. But that's not the only way that I could get 3 Jayhawk and 2 Wildcat fans. It might have gone Jayhawk, Wildcat, Jayhawk, Wildcat, Jayhawk, or Jayhawk, Wildcat, Wildcat, Jayhawk, Jayhawk. There's so many ways that this could happen. And so what I need to do is find out how many ways that can happen, because every single one of these is going to have a 0.02 probability. So let's figure out how many different ways I could rearrange those J's and W's. And what it really boils down to is it's a combinations of, I've got 5 people and I'm choosing 3 to be Jayhawks. Okay, and so if you do 5 choose 3, you get 10. Okay, so basically I have 10 different sets of these 3 Jayhawk, 2 Wildcats. So what I'm going to end up doing is multiplying these two numbers together, and so then I'd actually have a 20 or a 0.20 probability. That seems a little bit better. All right, so this is kind of our formula then. If I'm looking to get K successes, in our example it was 3 successes. The first thing you have to do is do that combination to see how many different ways you can rearrange them. And then you're going to take the probability of a success to the power of however many of them that I have. So in my case, I would have done a 0.8 to the 3rd power. And then here's your probability of a failure. taken to a power that represents however many of those that I want. So I would have done a 0.2 to the second power because I have 2 wildcats. Okay, so let's look at one here. Same situation, same probabilities, but this time I'm going to ask 7 people, and I want to know what the probability that exactly 2 say Jayhawk, because that's a success, of course. Okay, so combinations of. I'm going to ask 7 people, and I want 2 of them to say Jayhawk. Then I come back and look at, all right, well, the probability of a Jayhawk is 0.8, and I want 2 people to say that, so I'm going to have that twice. And then the probability of a wildcat is 0.2, and I'm going to want 5 of those so that it'll add up to 7 people. Okay, so when I enter that into my calculator, I get 0.004. That's very low. But here's the deal. That actually does make sense to me because we are predominantly Jayhawk fans, but when I ask 7 people, I'm only expecting 2 people to say Jayhawk. That seems low considering we're so strong on Jayhawk fans. Okay, so that would be a very low probability. All right, let's keep going. Let's try something that's not Jayhawk and Wildcat. Here's one. Find the probability of having 5 left-handed students in a class of 25, given that the probability of a success is 0.1. Okay, so we start off and we figure out all the different ways that you can rearrange these people. So it's going to be combinations of, I have 25 people, and I want to pick 5 left-handers. The probability of a left-hander is 0.1. And I would want to end up with 5 of those. And then the probability that you're not left-handed would be 0.9. And so I'm asking 25 people. If 5 are left-handers, then that means 20 have to be right-handers. All right, and then you type that in. Let's see if we get something reasonable. I end up with 0.06. Okay, well, that's kind of low. It's like 6%. But I think considering those probabilities and how many people you're asking, I think that that's okay. 0.06 is our probability. Okay, so now you have 6 practice problems that I want you to try. There's 4 at the bottom of your notes, but then turn the page, there's 2 more at the top of the next page. The answers are actually even listed there for you. I need you to pause the video and go practice doing those. Check your answer. If it doesn't agree, you can troubleshoot. We'll come back and go through them later, but for right now, I just need you to pause the video and work through those. All right, I have all your answers right here, so you can kind of check. If there was one that you struggled with, you couldn't figure out how to set it up, you weren't getting the right answer, here's how to do it. I would say that the main ones that you probably struggled with would have been this number 2, and what makes that tricky is when it says at most 2 will graduate. So that means it could be 2 graduate, or it could be 1 graduates, or 0 graduates. And since you're saying or, remember or means add, and so you actually have 3 situations and you have to add those all up. Okay, the other tricky one on those multiple choice tests like 3 and 5, on 3, since you had 5 answer choices, that's A, B, C, D, or E, well then you have a 1/5 chance or 0.2 chance, and then a 4/5 chance of missing it, that's 0.8. Same thing on number 5, only since there's 4 choices, those probabilities change. And then number 6, this is an important one. Make sure you know how to do number 6 here. This is kind of like that number 2 where it says at least 1. Okay, well, at least is trickier here than at most. At least 1 means that it could be 1 or 2 or 3 or 4, all the way up to 60, because we're getting 60 of these t-shirts. So that would take us pretty much forever to get all that done. So this is one of those scenarios where it would be way easier to do the complement of an event. Remember from your notes in 9.7 that you do the complement by taking 1 minus the probability of the opposite. So when I look at this, my list of options here goes from 1 all the way to 60. The only thing that doesn't include is the possibility that there were 0 defective. And so that's the opposite of at least 1 is 0. So I'm going to do 1 minus the probability that I get 0 defective shirts. And so then you can see how I set that up. All right, take a minute to pause the video if you need here and go through and check all of your answers on that. Okay, so then the next thing that we're really shooting for here isn't so much like what's the probability I ask and only 5 people say something. It's not always just that specific scenario. Sometimes what I'm really looking at is what are all the options available and what do they look like, how likely are they? So we're going to go back to the Jayhawk Wildcat, and I'm going to look at, and I'm going to ask 5 people. And I'm going to look at what are all the possible scenarios. Okay, so I start off and I'd say, well, and you fill in your chart as you go here. For the first one, what's the probability that if I ask 5 people, 0 of them say Jayhawk? Okay, well that would be combinations of, I'm asking 5 people and I get 0 to say Jayhawk. Probability of a Jayhawk is 0.8. I want 0 of those. Probability of a Wildcat is 0.2. I'm going to end up with 5 of those. And then we'll type that in the calculator. Okay, next, the probability of 1. A person saying Jayhawk. Well, that'd be combinations. Ask 5, get 1 Jayhawk fan. Probability of a Jayhawk is 0.8. I want 1 of those. Probability of a Wildcat fan is 0.2, and I'm going to need 4 of those. Okay, next one. It's going to be 5, and I want to get 2 Jayhawks. So that's a 0.8 squared times a 0.2 to the third. All right, I need you to keep going and then go ahead and type those numbers in your calculator so that we get the actual probabilities for each one of those. All right, so check over your answers and look and see if this is what you got for all of those. Now, what's interesting about this is when you go find all of these different probabilities, what you're finding basically is every possible scenario after I ask 5 people if they like Jayhawk or Wildcat. These are the 6 different possible outcomes that might happen. So you know this first situation or the second or the third or the fourth or the fifth or sixth would have to happen. And if you were to take and add all of those probabilities up, since these are all the possible options, they should add up to 1, or pretty close to 1. I did some rounding, and so certainly it could be off just a hair, but when you add those all up, it's a nice check. They should add up to 1. Okay, now what we're going to do then is sometimes, you can see those, but a graph of it kind of shows you a visual, and so that's kind of nice to see a graph. So let's come over here and let's graph these probabilities. So you need to take a minute, pause the video so you can fill in your chart or your graph with a scale. As far as how far you have to go up the side, it always just depends on what your probabilities are. My highest probability is a 0.41, so I just have to give myself enough room to go that high. Okay, go ahead and fill out your scale, and then we'll start with the graph. All right, so the probability of 0 people saying Jayhawk was very slim, just kind of a line there. Even for 1 was teeny tiny. That's probably bigger than that should be. Okay, 2 is a 0.05. Okay, so that's about halfway up right there. And then the probability that 3 people said it, now we're getting somewhere. All right, and then the probability that 4 people said it goes clear up to 0.41. And then you're back down, the probability of 5 is 0.33. Oops, that's not right. Let's come up, 0.33 is about right here. Okay, so there's my distribution. That's called the binomial distribution, where you see how those probabilities are distributed. You can see that this is definitely considered a skewed bar graph or a skewed distribution because it's very strong on the high and high on the larger end. And that makes sense since the probability of picking Jayhawk was much higher than the probability of picking a wildcat. Well, then we should be higher on the right end of this distribution. If it was flip-flopped, then you'd be high on the left end. Now, what would it look like if it was like an even probability? Okay, and that's actually leads us to next, which is flipping a coin. Okay, there would be an example. We won't go through this because we did it in class, but basically if you are flipping a coin and your probabilities are equal, whether it's heads or tails, then your distribution is going to be more even looking, where it's not skewed one direction or the other. It's kind of in the middle and kind of nice and even looking on both sides. And that is the type of binomial distribution that we will look at tomorrow. So today what you're doing is just the first part of your assignment. It's a worksheet. You work the first page and half of the next page, and you stop when you hit that line across the page. All right, good luck. Have fun.